Great scholars, let us consider some other problem on base numbers leading to quadratic problems. Base numbers leading to quadratic problems. Let us look at this type of problem given here. We have 102 base x is equal to 23 base 4. You have to find x. You have to find x in this problem given. Now we cannot change this to base 10 and still keep this the way it is. We need to change the two numbers to base 10 directly. Why? Because x here is not a specific base. X is not known. So I will just need to change the two numbers to base 10 directly. But if x was like a base 5 number or base 7 or base 6, I'll need to equate the base by changing this number to base 6 or changing the base 6 number to base 4. But right now, here is not known. And here is base 4, not base 10. So I need to change the two numbers directly to a base 10 number. So I'm going to start with this first. 102 base x. That will be, crown your numbers. 0, 1, 2. That will be 1 times x raised to power 2 plus 0 times x. 0 times x raised to power 1 plus 2 times x raised to power 0. That will be x raised to power 2 plus 0 plus 2. Recall that any number raised to power 0 is 1. So 1 times 2 is 2. So we'll have x squared plus 2. That's a base 10 number. I will also change this to base 10. 23 base 4, 0, 1. Crown your numbers. That will be 2 times 4 raised to power 1 plus 3 times 4 plus 3 times 4 raised to power 0. That will be 4 times 2, that will be 8, plus 1 times 3, that will be 3, and our answer will be 11. So these two numbers are in base 10. These two numbers are now in base 10. I can now equate them and solve the problem. So we have x squared plus 2 is equal to 11. So what will be x squared? It will be 11 take away 2. X squared is 9. Then s alone will be what? The square root of 9. Therefore, x is equal to plus or minus 3. That is, x is equal to 3 or minus 3. These are the two numbers of x. These are the two values of x. So we actually look for x. That is what we're going to have as the result. So solving this problem will give us this as the values of our x. X is 3 or minus 3. If you want to check your answer, put x in this place, it will give you 11. 11 in base 10. 11 in base 10. You're going to have 11 in base 10. Yeah, is that what you're going to have? Then if you choose to change your 11 in base 10 to base 4, that is, look at what I'm saying, to check your answer to see if you're right. Check your answer. When x is 3, when x is 3, we have s squared plus 2 is equal to 11. So that will be 3 squared plus 2 is equal to 11. That will be 9 plus 2 is equal to 11. That will be 11 is equal to 11. So we are correct. The two numbers here are in base 10. This is a base 10 number. So if you want to change your base 10 number to base 4 to see if you'll be right, 11 base 10 to base 4 to base 4. If you're changing a number that is in base 10 to a base below, you use the division method. So I'll be dividing 11 base 10 by 4. That will be 11 divided by 4. How many 4 and 11? We have 2, remainder 3. 4 cannot go into 0, remainder 2. So we have our answer 23 in base 4, which is this number given. So we are correct in what we've solved so far. The values of x are 3 or minus 3. So you carefully do this for me. Do this. Find the unknown. Find the unknown. You have 1. 142x is equal to 16. And 2, you have 110x is equal to 121. is 3. So you have to solve that problem yourself. Remember, this number is in base 10 because there's no specific base attached to that number. If there's no base attached to a particular number, the number is already in base 10. So carefully replay the video, get the best understanding, then solve this yourself. I'll see you in our next class. Thank you.